My name is Nicholas, and I'm here with two of my teammates, Ian and Jeffrey. Our other two teammates, Ritvik and Jonathan, could not be here today. We are a team in the robotics program at PACE, and for this year's exhibition, we want to build a self-driving, all-terrain vehicle. This ATV will be able to detect objects in its path and steer away from them. It will also be able to tell if there's a drop in ground level in front of it or beside it. This will allow it to steer away from drops and keep itself on the safest path possible. We will accomplish this by having ultrasonic sensors that will be positioned so that they can sense objects in front of the robot, and there will also be sensors looking down at the ground in order to detect holes or cliffs. We will be building and programming our robot using the Arduino parts and software. The body of our robot will be made out of balsa wood, and key components of our robot will be attached with metal rods. Note, due to the limitations of this program, we were unable to correctly show the placement of our front and back wheels. In our finished product, they will all be going down diagonally from the pivot point so that they do not interfere with ultrasonic sensors, and they give us the ability to put in our suspension systems at the bottom.
Include suspension, and a servo will be able to turn the front wheels with our steering mechanism, driven by the back wheels, which can pivot individually to keep the robot stable, but wheels and the steering mechanism will pivot as one. The way that we are going to do our suspension system is with elastics attached to the wheels and to the underside of our robot. These will let the wheels pivot outward and then come back into their neutral position. We will restrict the wheel's range of movement so that they do not fold under the robot or swing too far outward. The Arduino and the breadboard attached to the central platform. We will also have a raised part onto which 3 arms with ultrasonic sensors on them will be attached facing towards the ground. These will have a set distance in the program so that if they do not detect anything within the set distance, the motors will slow down and the robot will either turn or reverse. This will be dependent on which sensors are triggered. 4 more ultrasonic sensors will be situated on the front of this raised part and on the steering mechanism. These will be looking forwards in order to detect obstacles in the path of the robot and move away from it. The reason that we have 2 sets of ultrasonic sensors at different levels is so if there is an incline in the terrain, only the bottom sensors will detect it. This will allow the robot to continue forward, but if all ultrasonic sensors detect something, the robot will slow down and the steering mechanism will be activated.
Will consist of many different variables and many different outputs dependent on the situation. If the bottom forward-facing sensors are activated and the upper forward sensors aren't, nothing will happen, but if all of the sensors are activated, then the robot will reduce its speed and turn away.
We will showcase the robot's abilities on a map with several different terrains and obstacles for it to overcome. The landscape will be able to be changed every time the robot goes through the course, so that the robot will not be able to take the same path every time. There are many different things that will be incorporated into this map. These include freestanding objects that will be movable in order to alter the course, ascents and descents that will be built into the terrain, raised paths for the robot to traverse, and many other assorted obstacles and anomalies in the terrain for the robot to navigate through. We've individually tested all of the components of a robot, and now it is just a matter of putting the pieces together. The reason that we haven't assembled our robot yet is that we've been working on perfecting our drivetrain. We want it working perfectly before we permanently attach all of the other parts to the robot. Thank you for your time, and we hope to see you at the exhibition.